in the last video, we gave our code the ability to decide. We taught it one powerful question. If something is true, what should I do? Today, we're giving code the next thing every real system needs: a pulse, repetition, rhythm, because sensors don't check the world once, or robots don't move once, and even controllers doesn't decide once. It repeats again and again and again, and that repetition is a loop. So in this video, we're going to build loops step by step, and I'll show you the difference between a for loop and a while loop in a way that maps to real systems. So before anything, let's open VS Code and make a clean file. Before I get started with loops, I want to see some repetition, but I want to build it in the simplest possible way. So I'm going to print something, for example, and I'll print it like 5 times. I'm going to print like print, and then I'll just say pulse, and I'll just do again, and then I'll do it again, and then I'll do it again. That's 4, 5. If I run this right now, it's going to give me print 5 times. But imagine if I do this 5,000 times. I would have to write this 5,000 times. It's going to take forever for you to make it. So instead of writing print 5 times, or whatever the times that we need, we want the computer to repeat something for us, and that's where loops comes in. So I'm going to delete these extra lines, and I will show you something different. So now, instead of repeating the instructions ourselves, let's ask the Python to repeat it for us, and that's where loops comes in. The first loop most people learn in Python is the for loop. It reads almost like a sentence. Let's write it down. For I in range 5, print pulse. Let's slow down here and read this line carefully. So for I in range of 5, this telling Python for every value inside the range of 5 numbers, run the code underneath it. And the code that belongs to the loop is everything basically that is indented. So indentation in Python is not decoration. It defines structure of the code. Everything indented here belongs to the loop. Okay, so let's run the code and see what I mean by that. You can see that we're getting the exact same result as before. But instead of writing the same instructions 5 times, we wrote it once, and the computer handled the repetition. So this is the first time our code stops being manual and starts becoming automatic. I want to show you something important about this line. So right now we wrote range of 5. What does that mean? It means starts as 0 index, which is starts as 0 counting, and stop before 5. So it's a 0, 1, 2, 3, 4, and you stop right there. And then you print basically the pulses based on these indexes. But we can control this more. So what if we add our own range? So let's say, for example, we're going to do here, I want you to count from 2 to 7, okay? And here, let's just write I equal, because I want to see the counts. And let's see and run it. So now we're saying basically this: starts at 2 and stop before 7. So 2, 3, 4, 5, and 6, as you can see. So think of range as defining a boundary, where to start and where to stop. So now we understand something clearly. A for loop works when we know the boundaries. We define the start and we define the end. Just like we know that we're going to start at 2 and then we're going to stop at before 7, which is at 6. But real systems don't always know the end. They don't just say run exactly 5 times. If you have a temperature sensor, if you have a robotic system, they keep running until something changes. And that's where while loop comes in. Let me create a simple temperature example. Don't think of this as a real sensor yet. For now, it's just number that changes over time. So let's remove this and let's write temperature equal, let's say 30. Temperature starts at 30, okay? I want the program to keep running while the temperature is below 40. So instead of saying repeat 5 times, I want to say repeat while this condition is true. How do we do that? While temperature less than 40, while the temperature is less than 40, keep running the code underneath. The word while is condition-based repetition. It does not care about a fixed number of cycles, like the for loop that we used to do, where we identify what's the range. While loop only cares whether this condition is still true. Inside the loop, I want to see the current temperature. Let's print it. I'm going to say temperature, or I can just say current temperature, and we add the value here. What underneath the while loop, it belongs to that condition. Every time the loop runs, Python will print the current temperature. But if we stop here, guess what happened? The temperature will never change. So the condition will stay true forever. And this is dangerous, and I can show you later what does that mean. We need to update the variable inside the loop. So how do we do that? This means take the current value, which is temperature here, okay, plus equal to. Add 2 and store the result back into temperature. Another way I can do this, it would be basically temperature plus 2, okay? Or, yeah, I can just keep it that way, or I can do as before. It's more efficient way, like this. Take the current value of temperature, add 2, and store the result back into temperature. So every cycle, the temperature moves forward. So let's run this and slowly try to understand the behavior. Python starts at 30. It checks, is 30 less than 40? That's correct. Then continue. And then it adds what? It adds to the temperature. Right now, temperature is 30, is going to be temperature plus 2, so that means it's going to be 32. Go back here, run the while loop. Is 32 less than 40? Yes. Then keep running. Is 34 less than 40? 36, 38, until it gets to 40, and ask the question, is 40 less than 40? That's wrong. Then stop the loop. And that is the heart of a while loop. It repeats not because we gave it a number, it repeats because a condition is still true. Now we have something very important. A for loop is controlled by a range. A while loop is controlled by reality. But that also creates a risk, because if reality never changes inside the loop will never end. And I want to bring you that example. Why is it dangerous to not add the variable or the condition to stop it? What I'm going to do is same example, but this time I'm going to remove this line, okay? And carefully, we're going to run this, which I don't recommend this, especially if you're running multiple lines of code, and sometimes this can cause the computer to crash. But this is a very simple example, and it should be fine. Right now, I'm saying is this: while temperature is less than 40, keep printing current temperature. But we never change the temperature. So ask yourself, will this condition ever become false? The answer is no. It's going to keep running forever. There's nothing that is actually added to the values, to the current temperature value. So that means the temperature is going to stay less than 40. It's going to keep running. Let's run it and see what happened. You can see it now. It keeps printing again and again and again with no end. And this is called an infinite loop. The program is stuck repeating forever. And this is not a Python problem. This is a logic problem. So you can stop it here. We'll just kind of like keep running Control-C, and then it should stop. In every while loop, you must guarantee one thing. Something inside the loop must eventually change the condition. Let's add the missing piece. We say temperature plus equal to. Okay, so it means each time the loop runs, the temperature increases. Eventually, the condition becomes false, and the loop exists safely. And if we run it again, this is going to give us the correct answer. Now we understand something very important. While loop needs a path to stop, but there is something interesting. Sometimes we actually want a loop to run forever. I'm going to write something that looks dangerous. Let's do this. While true, print system running. So this condition is always true, will never stop on its own. Let's run it and let's see what happens. You can see here, this condition is always true, is going to keep running. So this is intentional. In real systems, this is how programs run. A device doesn't start, run once, and exit. It runs continuously. But here's the difference. Inside, let me just stop it because, okay. Inside that infinite loop, we use conditions to control that behavior. Now we've seen two important ideas. Loops can stop automatically when a condition changes, or they can run forever and be controlled from inside. The next step is to combine loops with decisions and make them behave like real systems. Now let's combine everything we built so far. So we understand repetition and we understand conditions. Now we're going to put them all together and make something behave like a system. So I'm going to start fresh. So first, we're going to import random so we can simulate changing values. And then also we're going to import time so we can slow the loop down and actually observe it. Then we'll start with temperature is equal, let's say 25. So we'll start with a given temperature like 25. Think of this as a simple sensor reading. Then I want the system to run continuously. So I'll use an infinite loop, but this time we're going to control it properly. We'll start with while true. What I'm saying here, run forever until we decide to stop from inside the loop, okay? So inside the loop, the first thing we want is change. In real life, sensor values don't stay constant. They actually change. If you see like temperature, it doesn't really give you like an exact amount all the time. It changes. Let's actually simulate that. Temperature plus equal random integer and -1 to 3. This line slightly changes the temperature every cycle. Sometimes it goes down by 1, sometimes it goes up as much as 3. And you can change that. You can put 4, 5. The value is evolving over time, and that's what we want. Then we want to print the current temperature. So we'll do print, and then we'll say temperature, and just print me the value of the temperature, of the current temperature at that particular moment. So we'll print the current temperature so we can observe the system, basically. Next, we're going to add a decision. For example, if the temperature gets too high, we want the system to react. What we will do, we'll use the if condition. So if temperature, the value temperature, reaches 35 degree, let's print overheat detected, and we'll turn on basically cooling system. For example, cooling system activated. This is exactly what we learned before. If something crosses a threshold, we act. But we also want safety. So if the system or if things gets too extreme, we should, let's say, stop or shut down the system. So let's put that condition. If the temperature reaches 45 degree, for example, I'm just giving a number, print critical limit reached, and let's say system shutting down. And then we'll add break. So this is our safety cutoff. If temperature goes above 45, we exit the loop. And finally, I don't want this to run instantly. Real systems operate over time. So we'll add here time, sleep, and we'll add 1. Now watch this carefully. This is no longer just a loop. This is a running system. So let's run it and see the outcome. As you can see here, it's running continuously. The values changes. It evaluates conditions. It reacts when needed, and it shut down safely when limits are exceeded. And as you can see, 38, 30, 39, 37, and you can see it's printing, cooling system activated, 45, 44, and it reaches the limit, and then it gives you critical limit reach, system shutting down. Why? Because the temperature reached above 45, which is 46, and that was the last temperature. This pattern right here is the foundation of how real machines operate.